Chapter 6-3. Now, what we learned in Chapter 6.1 and 6.2 was how to simplify a radical, right? And in 6.4, we learned how to deal with the power over roots. Why am I going back to section 6.3? I'm going back to 6.3 because 6.3 requires us to be able to add and subtract, multiply, and divide them. In order to add and subtract, you have to know what like terms are. So I wanted to make sure that you understood how to simplify a radical 100% before we decided to add like terms together. Maybe I'll understand that. So what we're doing today is we're adding and subtracting. In order to add radicals, they must have exactly the same index and radicand. Radicand is a new word for you guys. Radicand is the stuff underneath your square root symbol. It's the stuff underneath your square root symbol, your check mark. You with me? That's a radicand. That is what your base is, yes. It's what inside is what inside the radical looks like first before your base. Power over root is what that gets. Okay. After you check the index and radicand, then check for like terms attached to the radical by multiplication. Now, can you add 2x squared plus an x together? No. You can't add those together, so therefore, you're done. Now, here we go. 3 times the square root of 5x minus 2 times the square root of 5x. The first thing we're going to do is we're going to check our index, then our radicand, and then the number in front. So we have 3 things we're going to check here. So let's first check our indexes. What are my indexes on each one of those? 2. Do they match? Yes. My radicands that jump underneath the radical symbol, do they match? Yes. And now lastly, we check the jump on the outside. Would 3 and 2 be considered like terms? Yes. So what is 3 minus 2? So I have 1 square root of 5x, which just means I have the square root of 5x. Done. Square root of 5x, not here as well. What I want you to imagine is that the square root of 5x is some letter, let's say w. So it would be 3w minus 2w, which would be how many w's? 1w. What's w? The square root of 5x. That's what I want your brain to imagine, okay? Going on to example D. Please write it down. Oh boy. Okay. I need to do my square roots. So check my indexes. Here's my index. Here's my index. Are they the same? Yes. So now I'm going to check my radicands. Square root of 7, square roots of 5. Are they the same? No. Guess what? Done. Done. Go to the next one. Copy it down, please. I know, I figured I'd give them something to laugh about as they're copying down the problem. Okay. Check. What do we check first? Index to 3, index to 5. Nope. Strike. We're done. You can subtract some that don't have the same indexes or have the same radicand. No, you don't change a dark thing. Okay, you need to recognize when they are the same and when they are not. If things are not the same, they're not like terms, you can't put them in piles. When you empty out your piggy bank, you don't put a 50-cent piece in with a pennies now, do you? Because they're not the same. So you can do anything you want in our world without what you want. Okay, this is right off tonight's homework, off your worksheet. Number 1. 9 square roots of 3 plus 2 square roots of 3. We're not dumb to notice why y'all are going to have substitute paper. Now, I check my index. index. Are they the same? Yes. Check my radicand. Check my radicand. Are they the same? Yes. I checked my lovely number in front. Are they like terms by themselves out in the real world? Yes. So what is 9 plus 2? 11 square root of 3. Done. Number 5. Indexes are both 3. Check your radicands. X and Y. I'm done. I can't do anything else with it. Lock's in. Some things are just ugly. You can't fix ugly sometimes, but you can just accept it. Right?
I can accept this ugly.
Okay, these are like problems 1 through 6 on tonight's worksheet. Literally write on your paper in your notes like 1 through 6 on worksheet. Come on, y'all, don't be lazy. Let's stop the lead. Seven. Okay, this looks a little more difficult, doesn't it? But is it really? No, because I asked you, look at the 48. 48's ugly, right? Well, I need to make it look prettier. So far, we've been dealing with things that have been very simple, like square root of 3, square root of 5, square root of x, right? You've not had to simplify a radical yet. I need you to simplify this radical first. So I need to take 48 and divide it by 2. What's 48 divided by 2? Is that a perfect square? No, so let's divide it by 3. What's 48 divided by 3? 16. Is that a perfect square? Sure is, so let's use it. So I'm going to have 2 times the 4th root of 16 times 3. Plus, let's go to the next one. 243. Is that an even number? No, so it's not divisible by 2. Can I divide it by 3, please? What is it divided by 3? Is 81 a perfect square? Yes, so we're going to use 81 times 3. What did I tell you about fourths? If you look for the perfect squares, then you're automatically going to have a perfect fourth, right? So now, what is 4th root of 16? That comes out as a 2. 2 times 2 is 4 times the 4th root of 3. What is the 4th root of 81? 3 times 3 is 9 times the 4th root of 3. Now, does that look like what we were doing before? Sure does. Are my indexes the same? Yes. Are my radicands the same? Yes. Is my junk outside of them like terms? So what is 4 plus 9? So I have 13 times the 4th root of 3. That was more involved, but it wasn't something you couldn't handle. No, it was taking section 6.1 and 6.2 and simplifying first and then adding like terms. We all understand that. 12. I love video games. I don't remember what video game. Name that video game. I don't know. I know, I hope I do. Now, square root of 125. I need to simplify that. It ends in what number? A 5, so therefore it's divisible by 5. So what is 125 divided by 5? It is 25. Minus 2. Break down 20. 5 and 4. 4 is a perfect square. We like it. Square root of 25. Square root of 4. 2 times 2 is 4. Minus square root of 5. Are my indexes the same? Yes. Are my radicands the same? Yes. Is the junk in front like terms? Yes. So what is 5 minus 4? 1 square root of 5, which means I'm just going to write the square root of 5 now. You do not have to. I just want to make sure you all understood that 5 minus 4 was the 1. This is exactly like problems 7 through 12 on tonight's worksheet. Where is that from?
Not a good idea.
Wait, do it again.
Here we go. This is a little different. How are these two attached? By multiplication. Now let's say, for example, I were to have something that looks like this. What would you do? You would FOIL. Well, just because this looks ugly and this doesn't look as ugly, and you would FOIL this one on the right-hand side, should you still FOIL the left-hand side stuff? So the rules still apply. We have two binomials attached to multiplication, so therefore you still have to FOIL. Are we listening? This is very key. You multiply radicals with radicals and numbers with radicants with radicants. Numbers on the outside with numbers on the outside. Okay? You do not multiply an outside number with a radicand on the inside. You do not multiply a number on the outside with a number on the inside radicand. Do we understand what I just said? So let's do this. 4 times 5 is 20. 4 times 4. Those are both outside numbers. What's 4 times 4? 16. I tack on the square root of 2. Notice I didn't take 4 and multiply it on the inside of my radicand, which was 2. Do you understand that? I did not do that. You do not do that either.
What is the square root of 2? What do you?
You do not take 4 times 2 to give you 8.
No. What is that? The square root of 2 and then the square root of 2. When you put those together.
We're not there. You put the cart in front of my horse, so I'll do that. Okay, moving right along. 2 times 5. 10. Do you see I put the numbers on the outside together and I'm going to tack on the square root of 2. Do we see that? Go to the next one. Now, what do I multiply together? The numbers on the outside, which are going to be 2 times 4, which gives you 8. And then I multiply the radicands together. What's the square root of 2 times the square root of 2? The square root of 4. Does everybody understand what I just did? Radicands with radicands, numbers on the outside with numbers numbers on the outside.
Are you multiplying 2 times 2 or are you squaring 2?
I took 2 times 2. Just happened to be the same thing.
That would be the square root of 2 times 2. And that would be 2. Because 2 times 2 is 4 and the square root of
This right here will, let's go from left to right here. Can I do anything with 20? No, drop it down. Can I do anything with the square root of 16 times the square root of 2? No, I can't simplify the square root of 2, so I drop it down. Can I do anything with 10 square roots of 2? No, I drop it down. Can I do something with the square root of 4? Yes, that comes out to be 2. So now what is 8 times 2? 16. Do we all see that? Now, do I have any numerical like terms? 20. 16 is a numerical like term. Give me 36. Do I have any like terms to the square root of 2? What is that? 10 square roots of 2 to give me how many total square roots of 2 now? To give me 26 square roots of 2. That is done. Are you with me?
City square root of 15. We just put 8 times 15 instead of 8 times the square root of 15.
Write it down, please. All right, do this problem. Write it down, please.
That's what I said.
Yes, that's legit. Okay. Okay, FOIL, right? 3 times 5 is? 3 times the square root of 7 is?
3 squares is 7.
Plus 3 square root of 7. Square root of 7 times 5 is? Minus 5 square root of 7. Square root of 7 times square root of 7? Minus, you can either write this as 7 squared or 49, or in your head, what's it going to be? 7, it doesn't matter. I'm just showing my work so that everybody understands where everything came from.
You consider that to have one from?
Yep, these are all ones right here. Yep. Okay? Now, what is the square root of 49? This thing is a 7. So what is 15 minus 7? 8. 3 minus 5 gives me 2 square roots of 7. Do we all see that? This is kind of ugly.
This is done. This is almost one.
Those are okay. How would you rationalize this? You would multiply this by the cube root of x squared, because how many x's do I have to have down here to pull one out? I have to have a total of 3 because my index is a 3, so I have to have 3 x's inside there to pull one on outside. So I need 2 more x's inside there. So I multiply by the cube root of x squared. Do we all understand that? Yes or no? Excelente. So I'm going to put parentheses around this because this is the head of the body, the binomial. Everywhere the 2 goes, the minus the square root of the cube root of 5 tags along with it, right? So I distribute. I'm going to have 2 times the cube root of x squared minus, are my indexes the same? Are my indexes the same?
Yeah.
Since my indexes are the same, I can marry the jump underneath the radicals. I can marry the radicals together. So what is 5 times x squared? 5x squared. So that's going to give you the cube root of 5x squared all over. How many x's do I have down there now? 3. Can I combine the cube root of x squared with the cube root of 5x squared? My indexes are the same, but are my radicands the same? No, so I cannot combine them, which means the top is totally done, and I have to leave it alone just as it is. But this comes out as an x. Can anybody tell me what a conjugate is? For example, what's the conjugate of a plus bi? A minus bi. Why did we use a conjugate? What was it for? Are we allowed to divide by an imaginary number? No. So if I look at something like this, am I allowed to divide by a radical? No. But I have a binomial radical, don't I? Previously, when we rationalized with only one term. I have 2 terms there, don't I? So how do I get rid of it when there's 2 terms? Multiply by the conjugate. What's the conjugate in this case? What is the conjugate? The square root of 5 plus the square root of 2 over the square root of 5 plus the square root of 2. We all see that. Multiply by its conjugate, the denominator's conjugate. So I'm going to put parentheses around all of that. Because that's by definition what conjugate is. A plus bi, the conjugate is a minus bi. So now, what do I do at the top? FOIL. 3 times the square root of 5 is going to be 3 square roots of 5. 3 times the square root of 2 is going to be 3 square roots of 2. Minus square root of 10 times the square root of 5. What's that? Square root of 10 times the square root of 5, what is that? Square root of 50. Square root of 10 times the square root of 2. Square root of 20. And when you multiply conjugates together, what is the wonderful, beautiful thing about them? What cancels out? The inner terms and the outer terms cancel out, and you only have to FOIL doing first and last. So if I do my first term, the square root of 5 times the square root of 5 is the square root of 25, minus my last, the square root of 2 times the square root of 2 is the square root of 4. So from left to right, can I do anything with 3 square roots of 5? No. 3 square roots of 2, can I do anything with it? No. Square root of 50, can I do something with it?
No.
Yes, what's that going to be? 25 times 2. How about the square root of 20? 5 and 4. What is the square root of 25? What is the square root of 4? Okay, I dropped down my 3 square roots of 5. I dropped down my 3 square roots of 2. What is the square root of 25? So that's going to give me minus 5 square roots of 2. What's the square root of 4? So that gives me minus 2 square roots of 5 all over. What's 5 minus 2? All over 3. Do I have any like terms up top? Do I have any like terms to my square roots of 5? Yes, I have minus 2 square roots of 5. So what's that going to give me? That gives me square root of 5. Did we see that? And do I have any square roots of 2? Sure do. What's 3 minus 5? All over 3. What's understood to be in front of that square root of 5? A 1. So if there's a 1 understood to be there, do I have anything in common between the 1, the 2, and the 3? Is there a factor in common between 1, 2, and 3? No, except for 1. So there's nothing about this, which means this right here is my final answer. Tonight's homework is chapter 6-3, worksheet 1, evens only. Odds for extra credit. Y'all understand what I just said? I will not be here tomorrow afternoon. You guys will have book work to do, so please bring your books. Okay? Have study. Okay.